Once you've applied a material to your part and are rendering that material, you should be able to start the generative structural analysis workbench. Pick the static analysis. This enables you to evaluate the fixed boundary environment for the beam. Notice that you are in the generative structural analysis with this icon. And once you've done that, you'll notice also in the specification tree that you've created a links manager.1 and a finite element model.1 by default. And the links manager one, if you expand this specification tree, you'll notice that there is a link to that part. If you double click on beam, you'll notice that you go into the part design workbench and you can modify the part. If you double click back on the finite element model.1, you go back to the generative structural analysis window. And if you minimize the analysis one window, you'll notice that the beam cap part window is up. And so it is linked. Now, once you've done this, you want to be able to store your computations in an area where you will be able to find them. So I would recommend modifying the path to the storage area by either using that method, or you can double click on the results or computations in the specification tree and it brings up the window and you can modify that area, that storage space. You also notice that if you go to the octatree tetrahedron mesh, it has the size and the sag of the mesh. If you decrease this number, you'll get a more accurate result. And we'll go over that more in detail later on. Here we also have the properties, the solid properties, and we are dealing with the material aluminum, and the support is the whole body, the beam, and the name is solid property.1 by default. Now, it also creates a static case with restraints, loads, and a static case solution and some sensors by default. Notice that it needs to be updated. We need to create restraints and loads. First of all, though, I want to show you some more storage settings. You can set these options, and I just wanted to show you where that is at in case you needed to do that. Now, this is the restraints toolbar, and this is the advanced restraints. Notice that it's asking for a vertex, an edge, a surface, or a face I should say, and a virtual part. So I'm going to select the front face of the beam. You can select your axis system. We're just going to leave it to implicit. It names it restraint.1 by default, and notice it's red and they have arrows associated with them. Now notice if I deselect restraint translation 3, the arrow goes away. That means that I can move that part. It can translate in that direction, basically the X direction. I'm going to fit this back into the window, and notice now that I need to create a load. Here's our loads toolbar, and I'm going to create a distributive force, and again it's asking for a vertex, a face, or a virtual part. I'm going to select the top of the beam, and I've got a negative 10,000 pounds of force on it. And this is a distributive force, that's why you see 4 of them. And so it puts the actual force is the centroid of that surface. Now I'm ready to compute it, and that's the compute tool. I'm going to compute all of it. You can select mesh only. I've got the preview selection on, therefore it pops this computation resource estimation window up, telling us how much the computer's going to, how much memory and time the computer's going to use to compute it. didn't take very long on this computation. Here we have the load and the restraints, and they turn different colors. This is the image toolbar. I'm going to show you how to get to that in case it's not on your toolbar. Go to View, Toolbars, Image, and I'm just going to select that, put that down there. And we'll go over later in the next session how to view some of your images.